Every time you type a web address and hit enter, a quiet conversation begins between your browser and a server somewhere out in the world. In this episode, we're going to decode that conversation, what HTTP actually is, how it works, and what that little s in HTTPS quietly adds to keep things safe. So picture this. Two machines that have never met, sitting on opposite sides of the planet, somehow need to exchange pages, images, and data without any confusion. For that to work, they need a shared set of rules, an agreement on what to send, in what format, and how to tell whether it actually worked. That shared language, the one quietly making all of this possible, is HTTP. So here it is in one sentence. HTTP is the request-response protocol the web runs on. Your browser asks, the server answers. That's really the whole dance. It's plain text, surprisingly human-readable once you peek at it, and it's stateless, meaning each request stands on its own with no memory of what came before. Keep that last detail in mind, because it shapes almost everything else we're going to explore. To make that concrete, picture walking up to a coffee counter. You ask for a large coffee. That's your HTTP request. The barista either hands it over, which is the response, or tells you they're out, which is essentially a 404 status code. And tomorrow, when you come back, they won't remember you at all. That's what stateless really means. Every interaction starts fresh, no history attached. So let's trace that exchange. Your browser sends a request, something like get.index.html, basically saying, hey, give me this page. The server hears it, finds the file, and sends back a response. A 200 OK status, plus the page itself. And that tiny loop, it's not just for web pages. Every image, every script, every API call your apps make is this same back and forth, repeated thousands of times. That really is the whole web. So let's actually crack one open and look inside. The first line tells the server everything it needs to start, the method get, the path with its query string, and the HTTP version. Then come the headers, little key value pairs giving context, which host you're talking to, what kind of client you are, what content you'll accept, and, here's an interesting one, an authorization token proving who you are. For a post or PIET, you'd also tuck a body underneath. That's really all a request is, a method, a path, and a stack of headers. Now that method word at the start of the request, it's basically a verb telling the server what you want done. Get is for reading. Post creates something new. Put replaces a resource wholesale, while patch only tweaks part of it. Delete does exactly what it sounds like. And head is a curious little one. It's like get, but the server sends back only the headers, no body. Pick the right verb and half the conversation is already clear. And once the server has heard your verb, it answers back with a status code, a 3-digit number that sums up what happened. The trick is that the very first digit tells you the whole story. A 2 means success. A 3 is the server pointing you somewhere else. A 4 means your request was off in some way, and a 5 means the server itself stumbled. So before you even read the rest, that leading digit already frames the conversation. And that conversation we've been decoding. By default, it's happening completely in the open. With plain HTTP, anything you send, including something like a password, travels as readable text, visible to anyone sitting on the network path between you and the server. HTTPS doesn't change the protocol at all. It simply wraps that same exchange inside a TLS tunnel. So what used to be readable now looks like meaningless ciphertext in transit. That's the whole S, HTTP over TLS. If we picture the stack, it clicks into place. At the top, you've got HTTP, your familiar request and response, with its methods, headers, and body. Underneath that sits TLS, the encryption layer doing the actual scrambling. That's literally the S in HTTPS. And below both of them, TCP quietly handles the reliable connection. So HTTPS isn't a new protocol. It's just HTTP riding on top of TLS, riding on top of TCP. While we're peeking under the hood, it's worth noting that HTTP itself has gone through a few major versions. HTTP 1.1, back in 1997, handled one request at a time per connection, which got slow fast. HTTP 2 in 2015 introduced multiplexing, letting many requests share a single connection. And HTTP 3 from 2022 runs on QUIA over UDP for even fewer stalls. But here's the key. Each version mostly just makes the same HTTP faster. The requests and responses still look the same to you. And the best way to really get this is to see it for yourself. If you run curl with the iflag against any site, you'll watch the whole conversation play out. The lines starting with a greater than arrow are what your machine sends, the request, and the lines with a less than are what comes back, the response. There it is, a get for the homepage and a clean HTTP 200 with content type and content length describing the HTML on its way. No magic, just text. So, let's zoom out and put the whole picture together. When you click a link, your browser first asks DNS to turn that name into an IP address, then opens a TCP connection to that address, wraps it in TLS if you're using HTTPS, and only then sends the actual HTTP request for the page. The server replies, and that response is what finally lights up your screen. HTTP is really the last step in the chain, but it's the only one you ever see. Now that we've seen the whole chain, let's clear up a few myths that trip people up. HTTPS isn't a separate protocol. It's the same HTTP, just wrapped inside TLS encryption with the same methods and status codes you already know. HTTP itself doesn't remember you. It's stateless, and things like cookies and tokens are bolted on top to fake that memory and that little padlock. It only promises the connection is encrypted, not that the site on the other end is actually trustworthy. Speaking of cookies and tokens, they live inside headers, the small pieces of metadata that travel alongside every request and response. Content type tells the other side what format the body is in, whether that's JSON, HTML, or something else. Authorization carries who you are, usually a token or credentials. Cache control hints how long this response can be reused, and set cookie is exactly how the server bolts that fake memory onto a stateless protocol. Let's pull all of this together. HTTP is simply the ask and answer language of the web. Every exchange is a request built from a method, a path, some headers, and sometimes a body, met with a response and a status code in the 200s, 300s, 400s, or 500s. HTTPS is that same conversation, just wrapped safely inside TLS. And because the protocol itself forgets you the moment you leave, cookies and tokens are what quietly stitch your session back together. So if you're actually building for the web, a few habits go a long way. Always reach for HTTPS. Pick the method that matches the intent. Get for reading, post for writing, and let your status codes tell the truth, instead of dressing every failure up as a 200. On the other side, keep secrets out of plain HTTP and out of URLs entirely, because anything in the address bar tends to end up in logs, history, and analytics. If today sparked more questions than it answered, that's a good sign. And there's a whole Networking Explained series waiting for you, covering DNS, TLS, load balancers, and reverse proxies, each one building on what we just unpacked. And since HTTP is only as safe as the machine answering the call, the SSH Hardening Mastery course over at Dargslan.com is a solid next step for locking that server down. Before we wrap up, I've got a quick one for you. What's the funniest or weirdest status code you've ever run into in the wild? Maybe it was a classic 418, I'm a teapot. Maybe an entire wall of 500s on a Friday afternoon. Whatever it was, drop it in the comments. I genuinely love hearing these stories, and they're a great reminder that behind every status code, there's a real conversation happening. And that's HTTP demystified. If something clicked for you today, if the conversation between browser and server finally makes sense, consider subscribing so you don't miss the rest of the Networking Explained series. We've still got HTTPS, DNS, TCP, and a whole lot more to decode together. You can find everything over at Dargslan.com. Thanks for watching, and I'll see you in the next one.